Hello students, Jai Somnarayan. I am Professor Urvish Mewada, HOD Electrical Department, Sri Somnarayan Institute of Technology, Gandhinagar. I am the subject matter of Power System 2 subject, which is in the 5th semester Electrical Engineering, and GTU subject code for this subject is 3150911. Students, we are currently discussing the experiments related to the topics that we have covered in the Power System 2 subject. So till today we have covered all the theory topics of the Power System 2 subject, and this is the practical session for this particular subject. So and till today we have discussed the two experiments based on the topic that we have already studied. First is the performance parameter for the short transmission line, and second one is the performance parameters for the medium transmission line. Now today we are going to discuss the third experiment, that is MATLAB programming to find out the variation of the voltage regulation. So that we are from this experiment we are going to find out the voltage regulation corresponding to the power factor change. So yes, MATLAB program to find out the variation of the voltage regulation with power factor for long transmission line. So let us discuss how we can perform this using MATLAB programming. So for that we need to start the MATLAB software. So in MATLAB software in the program window I have programmed, or I have figured the program of the given system. So let us start with the program. So this is the date which is showing that the experiment that we have performed in this MATLAB, and this is the clear all, and CLS is the command to clear the screen, whatever previously we have done in this M file. So that will be clear using this window, using this command. Now yes, that let us write down the data, let us feed the data in this program. So this is the VR is the receiving, and voltage is 10 into 10 raised to 3. So R is the 36 ohm, X is the 73.1 ohm, Y is I into 5.055 into 10 raised to minus 4. Power factor is 0.9, receiving and power is 18 into 10 raised to 10 raised to 6. Now Z is equal to R plus X into Y. So these are the data which is given to solve the this program for the long transmission system. Now let us find out the IR magnitude is equal to PR by square root of 3 into VR into power factor. So this is the equation that we have already studied in the theory section. It is nothing but the P is equal to root 3 VI cos phi, and PF that we are taking from for this is 0.6 to 0.1 with an increment of 0.01, and IR angle means receiving end current angle is based on the power factor, so that's why A into cos power factor. So this is the command that we have figured in this program for IR angle. Now IR is equal to IR magnitude into the minus I into IR into angle, means IR angle. So this is the formula which can help us to find out the IR means receiving end current for this particular program, and this is the means method. This is how we can feed the equation to find out the receiving end current. Now IR1 is IR magnitude into I into IR angle. So this is again for IR1. Now from that we can find out the ZC. So ZC is equal to say square root of Y by Z. So this is the parameter that we are finding using the this program that we are feeding in the MATLAB program. So Vs is equal to VR by square root 3 into cos H into square root of Y into Z plus IR into ZC into sin H square root into YZ. This is the formula that we have already used for the long transmission system analysis in the theory section. Now we are in no load for the medium medium transmission line, or at the middle, that is ABS into Vs by 1 plus Y into Z divided by 2 plus Y into Z raised to 2 divided by 24. So this is the formula which plot the, or which define the value of VR at no load and VR at full load, that will be ABS into VR by square root of 3. So percentage voltage regulation equation, that is VR NLM minus VR FLM divided by VR FLM into 100. Now VS1M is equal to VR by square root of 3 into cos H square root of Y into Z plus IR1. Just one thing we have modified over here, this is 1, that's why we placed 1 over here in the previous equation of VS. So yes, IR1 into ZC into sin H square root sin H into square root Y into Z. Now VR NL1M is EBS VS1M, the value that we have find from this VS1M divided by 1 plus Y into Z divided by 2 plus Y into Z raised to 2 by 24. Now from that we can have the value of percentage voltage regulation, means regulated voltage, that is VR NL 1M VR FLM divided by VR FLM into 100. So plot means we will get this characteristic in terms of plot once we run this program. So the plot that we get, PF percentage voltage regulation, R PF voltage percentage regulation star. So this is the way by this means this is the method by which we can feed the data for the MATLAB programming for the long transmission system, and the labels which will be plotted on the graph, that will be X label. After once we run the program, these are the label that will be plotted on the graph. So X label 1 is the power factor, Y label 1 is the voltage regulation, title will be plotted, that is long line voltage regulation, and the text that will be appear once we run this program is V regulation versus lagging power factor and V regulation versus leading power factor. So here we are finding for both the power factors. Now I am running this program, and this is the result of this program. In this program you can see that for at around 0.796, around 0.8 power factor, the regulation that we get, it is 14.81. Now here we are getting three different plots. So first plot is for the V regulation versus lagging power factor, second one is the V regulation versus leading power factor, and third one is the resultant power factor corresponding to the voltage regulation. So this is the point which we can scroll on the line, and for different power factor value we can get the percentage voltage regulation without calculating, means without manual calculation. Now let us see whether our means program is correct or not by manually. So yes, we have the manual calculation also in this program, and after means taking all the values that we have taken over here, and we will solve this example, and let us check that what will be the output over here. So yes, this is our experiment for practical number 3. So let us start with the calculation. VR that we have taken 110 kV, so 11 into 10 raised to 3 voltage. R is 36 and X is 73.1. Z that we have taken 36 plus J 73.1, and Y that we have already applied. Y is Y that we have already into the data. So Y is the say J into 5.055 into 10 raised to minus 5, and P power factor is 0.9, and receiving end power that will be 28 megawatt. So let us find out the IR. We have all the values of values which are given in the data. So by putting all the values, the IR will be 104.972 ampere, and IR is equal to the 104.972 at angle phi r. So that's why we are putting the values of the angle over here. So we are having the cos phi r and j phi r, j sin phi r, because cos phi r is 0.9 corresponding to the cos phi r. We can find out the j sin phi r. So after putting all the values, the IR will be 94.474. so according to this, the J means complex value, that will be 45.756. Now let us find out the means ABCD parameters of this system. So A is equal to cos H into means this bracket that is J means Y2. So yes, after putting this values over here, means B is equal to under root of Z by Y into sin H into YZ, And now VR is equal to cos h into under root of yz. So B is equal to under root of say z by y sin h into yz. So VR is equal to, we are having the value of VR, that is 110 10 raised to 3. So it will be divided by root 3. So this is the value of the VR 63508.529 volt. Now Vs is equal to the equation, that is VR plus IR, and the corresponding ABCD parameters for this VR and IR will be will be multiplied with the VR and B will be multiplied with the IR. So sin h into under root of yz is equal to e raised to under root of yz minus e raised to minus under root of yz. So divided by 2. So after putting all the values over here, the sin h into under root yz will be 0.2071. This is the value of sin h under root of yz. Now under root of yz is equal to, these are the value that we have already calculated from the given data. So under root of yz will be under root of 0.04118 at angle 153.78. Now under root of yz will be in terms of a plus dB, that is 0.05, j 0.20, and under root of z by y will be 81.48 at angle 63.78 divided by 5.055 into 10 raised to minus 4 at angle 90 degrees. So after putting all the values, we will have the value of under root of z by y is 401.4809 at angle minus 13.11. So A is equal to cos h under root of yz. We are having all the values. So by putting all the values, we will have the A, that is 1.02085. So we are having the value of e raised to under root of yz and e raised to minus under root of yz. We are having all the values. So then after the B is equal to under root of zy sin h under root of y into z. So this under root of zy will be 401.84809 at 9 at angle minus 13.11, and this is the value of the yz that we have calculated, 0.2071. So after solving this, we will have the value of in terms of r angle theta, that is 83.1466 at angle minus 13.11, and 80.98 minus j 18.86 is the r angle theta form of the B. Now Vs is equal to, we are having the equation, that is VR plus IR, and the multiplier that we are using over here, that is A into VR plus B into IR. So we have all the values of A, VR and B, IR. So after solving this values, we will get that 864,832.6818 plus 8727.8996 at angle minus 38.95. So Vs will be, after solving this, that will be 71830.180 at angle 180 voltage. Now VRNL is equal to Vs by A. So we are having the value of Vs and we are having the value of A. So by dividing this two, we will get the 70363.11 volt, and the VRFL is VR. So that's why 63508.529 volt. So VRFL that we get from the VR is this. So after putting these two values, VRNL and VRFL in the percentage voltage regulation, that is VRNL minus VRFL divided by VRFL into 100. So percentage voltage regulation that we get, that is 10.8%. So yes, for different values of the power factor, we can put the values, means we can find out the value using manually by this way. So yes, in the plot we can also scroll it, means to find out the solution for the different values of the power factor, means corresponding to the power factor, the voltage regulation will be like this. So this is how you can scroll the means the cursor on the plot, and you will get all the values that you feeded according to the feeded program. So this is what I am done for this experiment number 3. And if you have any query or any doubt related to this topic, then we can solve your queries and doubt in our doubt solving session. Also feel free to call me to solve your doubts related to the topic which are related to the electrical engineering. Thank you very much, student. Thank you all. Jai Swaminarayan.